Did you catch this TED Talk?
Our estimate is that approximately 300 terawatt hours of battery storage is needed to transition transport, electricity, and heating and cooling to a fully electric situation.
In fact, it's hard to gauge how much energy we spend in an hour. But if we had to think about it, one guess would be that it would take about 50 years or so to produce this amount of energy. So, storage solutions should be prioritized for this urgent problem. And after careful consideration, Musk came up with the types of cathodes he expected should be used for this purpose. He says the main cathode will probably be manganese because this material can scale to very high tonnage. Thus, Musk and scientists have developed and tested a new manganese-based hybrid battery that can travel up to 1,000 kilometers on a single charge and achieve lower cost reserves. How can such a battery exist, and how superior is it to existing batteries on the market? Let's find out in today's episode of Tesla Car World. Welcome back to the channel. Before we begin, please show your support by subscribing if you haven't already and ringing the bell so you won't miss out on any of our interesting videos in the future. Now, let's get started with today's content. Gotion High-Tech, which is Chinese owned and US based, is one of the world's top EV battery manufacturers, and they have announced that they have a breakthrough in the form of a lithium iron manganese phosphate battery, which is production ready, and they say the unit can deliver a driving range of up to 1,000 kilometers from a single charge. Until now, only the more expensive nickel cobalt batteries have provided that kind of range. But on the other hand, the LMFP battery, which is also named the Astroino L600 LMFP battery, is providing cheaper, smaller, and even more powerful battery packs for electric vehicles by building upon the LFP chemical formula, which is familiar to batteries already in use by some electrical manufacturers, including BYD and Tesla. This company has seemingly solved the challenges of manganese dissolution at high temperatures, low conductivity, and low compaction density typically associated with the formula by using a combination of co-precipitation doping encapsulation, new granulation technology, and new electrolyte additives. So then, how can an LMFP battery provide 1,000 kilometers on a single charge? It's due to the high energy density of the Astroino battery that we can enable a range of 1,000 kilometers without relying on NCM materials. Cheng Chan, Executive President of the International Business Unit of Gotion High-Tech. Our Astroino L600 LMFP battery cell, which has passed all safety tests, has a weight energy density of 240 watt-hours per kilogram, a volume energy density of 525 watt-hours per liter, a cycle of 4,000 times at room temperature, and a cycle life of 1,800 times at high temperatures. In recent years, electric vehicles are becoming very popular as well, and they use primarily blade batteries utilizing lithium iron phosphate technology, and these types of batteries only hit a ceiling of energy density at 190 watts per kilogram. But adding manganese to the mix enables greater weight energy density within LFP batteries, which can reach to 240 watt-hours per kilogram, which is 1.26 times higher than regular LFP batteries. It can then be said that it's quite an upgrade, or a leap, for energy density. The 1,000 kilometers or 621 miles of range quoted by Gotion would be a huge increase in terms of what is currently available on the market. Volkswagen's new electric ID.7 upper medium car, for example, will have a range of up to 438 miles, which is nearly 1.42 times shorter than this LMFP battery. If we consider the current battery market for electric vehicles, this battery's single charge range has also nearly reached records set by customized electric prototypes, such as an electric concept car from Mercedes, the Vision EQXX, which broke its efficiency record of 1,202 kilometers, which is equivalent to 746 miles in a road trip from Stuttgart in Germany to Silverstone in the United Kingdom on a single charge of battery on the 22nd of June of 2022. An EV that has this LMFP battery just needs more than 200 kilometers more to break that number number, which is said to be a record in this electric vehicle battery industry. Additionally, in terms of energy density, 240 watt-hours per kilogram means it can store more energy in every battery cell and also minimizes the weight, which in doing so makes the battery pack smaller. This dual benefit will significantly improve the range of any vehicle that implements this type of battery. In recent years, LFP technology has regained the recognition of the market, with market share continuing to increase, explained Dr. Cheng Chan. Meanwhile, the energy density growth of mass-produced LFP batteries has encountered bottlenecks, and further improvement requires an upgrade of the chemical system, so LFP batteries doped with manganese were developed. But on the other hand, the cycle life of a 4680 battery at high temperatures is around 1,000 cycles depending on the charging method. It concluded that the LMFP battery is 1.8 times more efficient in terms of cycle life compared to the 4680 battery. And up until now, the 4680 batteries were considered ternary lithium batteries, with a shorter cycle life because they are now only utilized in electric vehicles. This breakthrough of this new type of battery gives potential to a lifetime of range that far exceeds the average lifespan of an electric vehicle. But is Tesla planning to use LMFP batteries? A significant publicly traded US auto company and Goshen High Tech have struck a supply and localization deal for the latter to receive 200 gigawatt-hours of lithium iron phosphate batteries from the former between 2023 and 2028. According to the China Automotive Battery Innovation Alliance, Goshen is presently the fourth largest battery manufacturer in China with a 55% market share, with CATL leading the pack, followed by BYD with 16.6% and CALB coming in third with 5.2%. However, Goshen has not disclosed the identity of its US client, only that it is a sizable and publicly traded US automaker with a sizable market valuation and a prominent position among the world's automakers. They further stated that Goshen had maintained a long-standing and positive cooperative relationship with the company and that it had an excellent credit rating and good performance capabilities. This mysterious automaker is allegedly Tesla. While a large US automaker may be just one among several, the majority of automakers are now making significant progress with their electric car plans. Technically, it could be any US automaker, but Tesla certainly fits the bill. Additionally, since there is currently no US manufacturer of iron phosphate battery cells, Tesla faces a challenge in switching all of its standard range vehicles to the battery chemistry globally, as it just announced. The fact of the matter is, they mentioned a large listed automobile company in the US, and there's no larger listed automaker in the US than Tesla. In fact, you may be aware that some of Tesla's vehicles employ LFP batteries. To be more precise, the car maker has only lately begun utilizing the chemical in its standard range vehicles in the US. This statement from Goshen was shared by sources as expansion and localization of production lines. US Guoshuan agreed to allocate the company's existing or new domestic to build production capacity and build new production capacity in the United States to meet the customer's battery procurement needs. This agreement also mentions using the cells in electric cars and other applications, which could mean stationary energy storage products like Tesla Powerwalls, Power Packs, and Megapacks. But the biggest tell of all might be the actual volume involved in the deal. 200 gigawatt hours of LFP cells between 2023 and 2028 is a lot. Considering LFP cells are used for smaller and shorter range vehicles, the deal could support the production of over 500,000 electric cars per year. As we know, Tesla has been open about its shift to LFP cells and is the only automaker that would need that many LFP cells in the US based on their production goals. All of the evidence proves that Tesla could be behind the deal. Another and more crucial factor is that Tesla's officials announced they will test this new battery. Tesla will use batteries named M3P with LMFP cathodes in the fourth quarter for the production of the Model Y with a 72 kilowatt hour battery. However, all batteries in this shipment come from CATL. After receiving these batteries, Tesla will carry out tests and will be able to start using them for EV production within just 3 months after receiving them. Thus, the start of production with new batteries will begin in 2023. After Tesla tried them out for 3 months, the report also indicated that the lithium manganese phosphate batteries used in the batteries will be supplied from Shenzhen City, which plans to start production of 110,000 tons of LMFP material in the second quarter of this year. Additionally, at the end of July, CATL Chief Scientist Wu Kai said that the M3P battery will already be in mass production and will be used this year. This catalyzed battery is based on the new material that has higher energy density than LFP batteries and a lower cost than normal lithium batteries. Several months ago, Tesla reported that CATL was already testing the M3P batteries and had sent some of them to car manufacturers for testing. And now we are getting information that Tesla will soon receive them and use them in the production of the Model Y in 2023. The company announced that it will commence mass production of the production unit in early 2024. But by how much is the LMFP battery cheaper than other batteries that are available on the market? The key reason these batteries are going to be cheaper than lithium iron phosphate batteries, which are available today, is because of the addition of manganese. It allows these companies to put less lithium into the pack. That's the biggest advantage here, because lithium is the most expensive component of the battery pack. Refined battery-grade lithium is quite expensive, even though the price has come down drastically this year. For instance, the prices for hydroxide-grade lithium averaged $75,000 per ton. However, at the end of 2022, it was at $81,500. Meanwhile, lithium carbonate prices in China receded to 475,500 Chinese yuan per ton, which is equivalent to around $71,000 earlier this year. It was once at a record high of 500,000 yuan, or a little less than 75,000 US dollars in late 2022. However, the prices of lithium carbonate and lithium hydroxide, which are raw materials for making electric vehicle batteries, are still high from the prices in previous years. With that trend, putting manganese into the battery to use less lithium is needed, because that's one of the reasons that LFP batteries are more expensive than they already are. The amount of lithium needed for LFP batteries is higher than what is needed in an LMFP battery chemistry. Additionally, the agency pointed out that due to the abundance of manganese ore resources in the world, the cost of LMFP batteries will be lower than that of LFP batteries with regard to the installation cost of batteries. The company expects that its LMFP batteries will cost 5% less than conventional LFP batteries, which means a cost of around 114 US dollars per kilowatt hour, due to most LFP batteries costing $120 per kilowatt hour. Moreover, the lithium-ion battery in an electric vehicle is the most expensive, typically costing up to $19,200, which would be as much as 16.84% more expensive than the LMFP battery. But what about the charging time of the LMFP battery? Is it optimized? Dr. Cheng confirmed that you can have a cup of coffee and rest at the charging station, and the battery will be charged from 10 to 80% within 18 minutes using the step charging. The main reason is that the LMFP cathode materials have attracted worldwide attention due to their good electrochemical performance and high operating voltage of up to 4.1 volts, which is 1.2 times higher than that of the LFP voltage platform, which is only at 3.4 volts. Furthermore, Goshen High-Tech has made significant advances in the design of the battery pack itself. Thanks to this innovative design, the company has reduced the weight by 32%, which is almost a third, and reduced the length of wiring used within the pack from 303 meters to just 80. The volumetric cell-to-pack ratio has reached 76%, outperforming other batteries currently on the market. The company also made other breakthroughs with the battery's design, which reduced the number of structural parts by 45%. But more importantly, how safe is the LMFP battery? Goshen High-Tech claims that their LMFP battery has passed all penetration, hotbox, overcharge, over-discharge, thermal runaway, crush, and short-circuit tests based on the latest standards. The test was completed without any fire or malfunction. The battery pack uses thermal insulation materials that can withstand temperatures of up to 1200 degrees centigrade, which is 20 times higher than LFP batteries. It can typically operate within a temperature range of up to 60 degrees centigrade. The battery also provides 4 layers of rapid heat exhausting channels around the corners of the battery to help dissipate heat and cool the battery much faster. During operation, it is inevitable to produce heat that affects the operating capacity and life of the battery. Intrinsic safety is also the main advantage of the LMFP battery pack. The thermal decomposition temperature of manganese, the materials it used, is much higher than that of ternary materials such as cobalt, nickel, or aluminum, which makes the batteries intrinsically safer. What's the background of LMFP batteries at Goshen High-Tech? Goshen is a leading company in the field of power lithium batteries, aiming to make green energy more accessible and sustainable. It has developed 2 types of batteries, NCM and LFP, which are both widely used in energy storage systems due to their high efficiency, safety, and cost. However, to further improve the energy density, Goshen has also invented a new type of battery, the LMFP, which stands for lithium iron manganese phosphate. LMFP is a novel battery material that Goshen High-Tech has been researching and developing for over 10 years. It uses advanced technologies such as co-precipitation doping, encapsulation, granulation, and electrolyte additives to overcome the challenges of LMFP batteries such as low conductivity, low compaction density, and manganese dissolution at high temperatures. These challenges used to limit the performance and application of LMFP batteries in electric vehicles. Now, Goshen High-Tech has successfully solved these problems and achieved the commercialization of the LMFP battery. The company is planning to build a $2.3 billion battery factory in northern Michigan, which will create about 2,300 jobs and boost the local economy. The factory will produce LMFP batteries for electric vehicles and other applications, demonstrating Goshen High-Tech's commitment to innovation and sustainability. So how much will LMFP grow and occupy in the market between 2022 and 2030? LMFP batteries are a new trend in the power battery industry. They are an improved version of LFP batteries that have many advantages. Many companies in the automotive, battery, and cathode material sectors are investing in this field. The LMFP market is expected to grow significantly from 2022 to 2030. The market is stable in 2021, but it will increase as more players adopt new strategies. By 2040, LMFP batteries could have a 6% market share, surpassing other alternatives like sodium-ion batteries. Some of the major global players in the LMFP market are Lithium Australia NL, Nanoloy BV, Shenzhen Dynanonic Co. Limited, Beijing Eastspring Material Technology Co. Limited, Contemporary Amperex Technology Co. Limited, XTC New Energy Materials or Xiamen Co. Limited, Guangdong Guanshua Sci-Tech Co. Limited, Lithitech, and BYD Company Limited. The last 3 companies I named had about 1% of the revenue in 2021. The demand for LMFP batteries is growing because of their applications in electric motorcycles, electric cars, and energy storage. The LMFP market has different product types based on the synthesis methods, such as high-temperature reaction method, hydrothermal synthesis, and co-precipitation method. The most popular type in 2022 was the high-temperature reaction method. The regions that dominate the LMFP market are North America, especially the United States, Canada, and Mexico. Europe is also a strong market, with countries like Germany, the UK, France, Italy, Russia, and Turkey. Asia and Pacific is another important market for LMFP batteries.
We've got a number of innovations that we think will be quite effective in the refining that haven't been done before. Maybe that's a good point to...
Exactly. A revolutionary new battery technology named NMC532 is the most suitable fast-charging battery. The ratio of N nickel, M manganese, and C cobalt in the cathode is 5 to 3 to 2, hence the name. This composition enhances the thermal stability and safety of the cathode. It also enables ultra-fast charging up to 5C. But how was Tesla's new battery developed to last 4 million miles? One of the biggest concerns about EVs is that the batteries will need replacing after a few years at great expense. But a Tesla researcher, Professor Jeff Dahn at Dalhousie University, is getting ready to throw out this idea and demonstrate that NMC532 batteries have the ability to last longer with proven 4 million miles, which means almost 6 million kilometers. It is truly becoming an heirloom for us to pass on to our children's children's children. Tesla enthusiasts are likely to have heard of Jeff Dahn already. He's a professor at Dalhousie University and has been a research partner with Tesla since 2016. His focus has been to increase the energy density and lifetime of batteries as well as reduce their cost. Dr. Dahn has met huge success along with his colleagues on his research team with the NMC532 battery design that could last 100 years under the right conditions. For example, in the US market, the average vehicle age is 30 years, doing 14,000 miles per year, which means the lifetime distance driven by an American car is 420,000 miles. After a bit of calculating, the lifespan of the NMC532 is 9.5 times longer than the lifetime of an American car. How much will the price go for the NMC532 battery?
A majority of our battery packs are iron-based, not cobalt. And then our other battery packs are nickel-based, and not cobalt. The nickel batteries use a little bit of cobalt as a binder, but only a tiny amount. In contrast, your phones all use 100% cobalt. But even for the small amount of cobalt that we do use, we will make sure, 6 ways to Sunday, that no child labor is being exploited. Obviously, we're a company that cares a lot about doing the right thing, and we don't want to delude ourselves or delude anyone else.
The single crystal cathodes that Tesla wants to use degrade a lot slower. Additionally, the cathode is currently being manufactured with nickel, aluminum, and cobalt. However, the research strongly suggests that the cathode of the NMC532 battery can be made using only nickel and aluminum. This effectively means going cobalt-free. Therefore, the price of the NMC532 battery will be much cheaper than previous batteries such as LFP or traditional lithium batteries. This is due to the fact that it has been proven in practice that the price of the final battery product is determined by 80% of the price of the raw materials it uses. In 2023, the price of 1 metric ton of nickel stood at some $21,970, which is 2.49 times cheaper than the average price of cobalt at $54,840 a ton. So it is estimated that the price of the NMC532 battery can be only about a third cheaper than traditional lithium-ion batteries that use up to 20% of the cobalt in each battery unit. We know Tesla is keen on going cobalt-free to avoid using up the limited reserves our planet has and to refrain from getting involved in illegal child labor that some cobalt mines have been accused of taking part in. The NMC532 battery has become Tesla's proprietary technology. Tesla recently renewed its contract with Dahn's team, securing an even more long-term partnership. In addition to that, Dr. Dahn added Dr. Chongyun Yang and Dr. Michael Metzger to his team to further enhance the team's capabilities. They have researched and optimized a lot of performance possibilities for Tesla's electric vehicle batteries, and more importantly, on behalf of Elon Musk and Tesla, Dahn has filed for a patent on the new battery. They have confirmed that their NMC532 battery is particularly useful for self-driving robotaxis and long-distance electric trucks, two products that Tesla is focused on developing. Tesla is a leader in electric vehicles and sets the direction for others in the industry. Its amazing sales performance is partly due to its industry-leading power, battery, and other key car parts. Tesla's research and development team has made a significant improvement in their power battery technology. In addition, the new battery developed by Tesla in collaboration with Don's team, which has the characteristics of long-term energy storage, will perhaps also be used in Tesla's energy storage products. It's the latest evidence that Tesla is at the forefront of the application of this battery technology. But let's talk about why this battery has such a long lifespan. The lifespan of current Tesla batteries can be affected by certain elements, including temperature, discharge activity, faster charger use, and driving habits. It's believed that Tesla batteries typically last approximately 1,500 charge cycles. However, Tesla's researchers have developed the battery to last for a very long time. It can be charged and discharged almost 2,000 times without losing its capacity. The battery could then effectively work for up to 100 years without decaying. Dr. Don is considered one of the pioneers of batteries whose research direction is to improve the energy density and life of batteries as well as to reduce their cost. And the real proven reason to extend the life of the NMC 532 battery is the switch from polycrystalline to single crystal cathodes, which don't break down so rapidly during the charge-discharge cycle. And the key to making the NMC 532 battery last longer is changing the type of cathodes. Cathodes are the parts that store and release electricity. The old cathodes were made of many small crystals that would crack over time. The new cathodes are made of one big crystal that is more durable. Dr. Don has been testing cells based on his adjusted chemistry. Apparently, this type of battery has been going strong, and after 4.5 years of continuous cycling at room temperature, they have only seen 5% degradation. This would mean that they could power an EV for 4 million miles before needing to be replaced, 6 million kilometers. Furthermore, NMC 532 can store about 275 watt-hours per kilogram, which means it can power a device that uses 275 watts for 1 hour with 1 kilogram of the battery. LFP, or lithium iron phosphate, can only store about 90 watt-hours per kilogram, which is 1/3 that amount. It can then be concluded that the NMC 532 batteries have better energy density than LFP batteries. This makes NMC batteries better for applications that need small batteries with moderate power capacity. But another important factor is its chemical composition. Here's a simpler way to explain the difference between the NMC 532 battery by Tesla and the NMC 811 battery that is being researched and developed by LG Chem, Samsung SDI, SK Innovation, and CATL. The numbers after NMC show how much of each metal is in the battery. For example, NMC 532 means 50% nickel, 30% manganese, and 20% cobalt. Meanwhile, NMC 811 means 80% nickel, 10% manganese, and 10% cobalt. The more nickel there is, the more energy the battery can store. But the more cobalt there is, the more stable and safe the battery is. So there is a trade-off between energy and safety. But then, how long does it take for the NMC 532 battery to charge? Well, it's called a fast charger for a reason. It can apply 5C charging technology. This fast charging technology allows to increase battery charging efficiency while shortening charging time. With this advantage, it is estimated that it can fully charge up to 90% in 12 minutes. The material of the cell is important for fast charging. The positive electrode, the negative electrode, the diaphragm, and the electrolyte of the cell all need a certain fit to have a higher electrical conductivity. That's why the new formula allows NMC 532 to be the most suitable fast charging battery with its higher thermal stability, higher degree of safety, and its ability to charge ultra fast. Combined with proven stacking technology and manufacturing processes, these new battery packs are made to be safer and more stable than ever. Besides its application for electric vehicle battery production, this is a more efficient source of energy for consumer electronics, UAV, or drones. The NMC 532 fast charge battery increases charging speed by 60%, which is very beneficial for applications such as agricultural spraying drones, which means plant protection drones, and mapping UAV as eVTOLs. So how will Tesla go about developing this battery?
So the demand is like quasi-infinite here. We're expanding Gigafactory Nevada for the in-house cell production. So we're aiming for 40 gigawatt hours a year, both in California and in China, but I think long term, this will be much greater than this. I mean, I would say I wouldn't be surprised if long term the stationary battery pack activity went well in excess of 500 gigawatt hours per year.
Currently, Tesla uses about 90% of its battery cells for its lineup of EVs and the other 10% for energy storage products such as Powerwalls and Megapacks. It has worked to secure the maximum battery supply capacity via a number of different deals and partnerships. Moreover, the automaker is producing its own batteries in multiple locations and is already considering getting into the lithium refining business to ensure the huge demand that even remains stronger in the future. To achieve that aim, Tesla will build a new battery factory in Shanghai, increasing investments in the battery sector. This is on top of its renovations of its 2 gigafactories, one in Nevada and one in Fremont, California. This was signed by Tesla and Shanghai on April 10th of 2023. It could open rumors that the new factory that is about to be built in Shanghai is being used by Musk for the research and production of the new battery formula, NMC 532. Additionally, many arguments also assert that with the chemistry of the NMC 532 battery, the Chinese market is an ideal location for this production process. It's really hard to know what Musk will do with his massive plans, but one thing is for sure, he never disappoints with any project. Are you curious about the latest battery project of the Tesla company? What about this new battery do you like best? Let us know in the comments. So that's it for our scoop on Tesla's latest battery project, but how about we move on over to what you really want to hear about? Tesla has broken the silence about Cybertruck production at Giga Texas. The Tesla Cybertruck is a highly anticipated electric pickup truck that is expected to launch in 2023. It has attracted about 1.8 million reservations from people who want to know when and how many deliveries will take place. The Cybertruck has a futuristic design and claims to offer impressive performance, range, and features. Some of them include a bullet-resistant body, a tonneau cover that can support a person's weight, and a towing capacity of up to 14,000 pounds. Cybertruck has been seen testing in California, and Tesla has also shared some images of the production progress at its Gigafactory in Texas. Additionally, Tesla plans to bring the Cybertruck to New Zealand for final cold weather testing before it goes on sale. There's a video of Tesla's Cybertruck production taking place on lines at Gigafactory Texas that has been leaked, confirming the automaker is continuing to make strides in its initial builds of the all-electric pickup as deliveries near. Tesla has been building the Cybertruck at Gigafactory Texas since the first quarter, as alpha prototypes were shown being manufactured in photos released by the automaker during the first earnings call of 2023. However, things in Texas are evidently moving forward, and production of the all-electric Cybertruck is now being shown in a leaked video of the manufacturing lines within the factory. This video shows a portion of a Cybertruck frame going through the body in white, or BIW line. BIW is a stage in automotive manufacturing where a frame has been joined together and occurs before any paint is applied. People have seen the Cybertruck being tested in California and recently Texas, where Tesla has a new factory. The factory has 2 huge machines that can make the truck's body parts from metal. These machines are called gigapresses, and they are the largest of their kind in the world. Tesla plans to start delivering the Cybertruck to customers in the 3rd quarter of this year, according to its CEO Elon Musk. Furthermore, Cybertruck rear castings were spotted there, along with other hints that production is nearing. The massive rear pieces were laying on the ground outside the factory, and there are no less than 45 casted components laying on the ground outside the Austin manufacturing facility, which indicated that Tesla might soon start low-volume production of the much-anticipated Cybertruck. If these are in fact rear castings for the upcoming all-electric pickup, it means the Cybertruck's rear is made up of no less than 5 big components, including 1 big casting for the bottom of the bed and 4 more pieces for the sides, as revealed in an earlier leaked photo showing an unfinished truck on the assembly line. These latest castings look different from the ones spotted last month. Back then, there were just a handful of casted components captured on video, but this time around it looks like Tesla has stepped up its gigapress game, with almost 50 components waiting to be put together to make a car. Or a truck in this case. Musk has said in the past that the upcoming truck was a tough product to design, and that it'll be able to cross rivers, lakes, and even the sea. Therefore, we still don't know for sure what Tesla's all-electric pickup will bring to the table, but from various leaks and spy shots, we can expect the Cybertruck to come with an adaptive air suspension system, rear wheel steering, the firm's latest hardware for computer, a revised yoke-style steering wheel, and a single windshield wiper. Tesla has also reportedly started reaching out to suppliers and has hinted toward an annual production rate of nearly 400,000 vehicles annually. It had told its suppliers to be ready for Cybertruck release candidates in late August and production in early October. That's all for today's video on the latest news about Tesla's latest battery project, the Cybertruck, and Tesla's Giga Texas factory. How do you feel about the new features and specifications of the Cybertruck? Are you excited to see it rolling off the production line soon? Feel free to leave a comment down below. In the meantime, we hope you enjoyed the video. If you did, please smash that like button and join our Tesla Car World family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.